we're super happy to welcome you for this very first demo day combo. So why do we call it the very first demo day combo? It's because it's the first time that we have both our data science students, full-time data science, as well as full-time web development students pitching together. So it's the very first time in Tokyo that this happens, which means for you guys online joining us, you're going to be super lucky because you'll see a few data science projects, a couple of those, as well as web development projects. We're not going to make it too difficult for you. We're going to split those two. So we'll actually start with our data science students. And then once data science projects are done, we'll switch to web development. So my name is Sylvain. I'll be your host for tonight. I'm going to take just a minute to introduce the team. We have Douglas at the computer here. We have Jan, who's going to pass in front. Hello, Jan. We have Sasha in the back. You may not see her, but she's doing a ton of work behind, making sure that you can see us on Zoom. And we also have a ton of teaching assistants in the room as well, who helped us throughout those 9 weeks. So I'm going to introduce right now what to expect from our data science pitches. So we had 6 students for this second data science bootcamp in Tokyo. It was a full-time bootcamp, so they studied with us for 9 weeks, and they went from the very, very basic of Python through data analysis, and then moving on to something a little bit more advanced, decision science. And after that, they started moving into more complex stuff. So they studied with us machine learning, deep learning, as well as data engineering, which means how to use all of those projects, how to use all of that data and make it available for users. And the last 2 weeks of the bootcamp, they worked very hard on the projects that you are going to see tonight. Some of our data science students had some technical background. We actually had one developer working at a startup here in Tokyo. But some of them didn't have much technical background, and they went through the bootcamp, like that advanced bootcamp within 9 weeks with us. I think we are ready to jump in the very, very first pitch for tonight. And actually, for the very first pitch, we'll have someone online joining us. I believe that Janice is almost ready to go. This is the very first data science pitch for tonight, and we're super happy to welcome Janice. Janice, you ready to go?
Okay, thank you. Hi, good evening, everyone. I'm Janice from DEFT, and today we're going to talk about data extraction from textbook images. So before we start, I would like to acknowledge that this data set was provided by Anot and Linago, and without them, this project would not be possible. And also it will not be possible without guidance and help from everyone at Wagon Tokyo. Thank you. So let's get back to the topic at hand. So data extraction from textbook images. So why extract data from textbook images? Because we want to make unstructured data into structured data so that we can put it into an application. So some examples of how this is useful is, for example, in this case, for Japanese language teachers and schools, they have materials in paper format, and they struggle to make their engage students online. So they need a way to get their materials information from their materials into an online format where their students can access and interact with it. And I don't know for you, but I can't say for everyone, but for me, like carrying up so many books around is really tough. So I would like I would like to be able to extract that data and put it into a smartphone application that is more easy to carry around. So this is where data extraction of images comes to the rescue. So from this process, we are going to be able to extract the data from the image in the textbook and make it into an application that will be easier for everyone to use. So how are we going to do data extraction? To do that, we need to use a tool called OCR. So OCR stands for optical character recognition. It's a tool where we are able to get information from typed text, handwriting, and printed text and make it into a format where machines can understand. So let's think about it. Can we only use OCR for text extraction? Yes, not sometimes, but not always, because OCR sometimes is not able to detect the layout of the page. So on the example on the right, you can see that OCR 2 was able to detect the text, but it was not able to detect the item sections. So we need to use another process called data annotation. And data annotation is a process where a person goes into a data set, assigns labels to certain sections so that machines can understand it. So in the example below, someone goes into an image and selects the sections and assigns a label to it. For example, in this case, Japanese word and Japanese sentence. So problem with data annotation is it takes time, and time is money. So this is not a scalable solution. So we need to be able to extract data from a lot of images, but not the entire data set. So Team DEFT solution is to use OCR to pick up the text from each image and to use some data annotation to train machine learning models to classify the text. So we're going to use OCR for getting the text and data annotation for getting the labels, and put that into a model to produce a structured result. So the data set that we're going to use is a collection of images from a textbook made for the Japanese exam. So our steps that we took was, first, we used an open source OCR tool to detect the text and to create boxes. Next, we use from the labels from annotated data, we get it and match the output from the OCR tool with the labels from annotated data by box positions. So in a nutshell, our solution looks like this. So we use OCR tool to create boxes and get the text, and match the boxes with the annotated data levels, prepare the data, put it into the model, and get the output. So I want to talk about some challenges that we faced in this project. So we'll go through each one by one. First is character recognition. As we are using an OCR open source tool, sometimes there are spelling and spacing errors. For example, here of applause, there should be a space in between. So to solve this solution, we implemented a spell check function that is able to catch these errors and hence correct it. The next challenge was recognizing the sections. As I mentioned previously, sometimes OCR tools are not able to detect the layouts of the page. So what we did here, how we solved this problem, was we used the numbers as a reference point to make item boxes. So for example, 1749, we were able to make an item box and get the area and get all the items from that area and assign it to an item number. In this case, 1749. Next challenge was getting labels. So boxes have different positions, and sometimes boxes can overlap with each other. So this is a problem. And how we solved this was we matched the boxes by using 60% of area overlap. And so this is our project journey. Like life, there's ups and downs. So first, we needed time to understand our data set. And next, we made a front end to understand what output we're going to expect. Then we made a simple model with low accuracy in the beginning. However, after adding more features and balancing our data set, we were able to improve our model accuracy. And the results of this journey are, we were able to make a model with 86% accuracy. The model that we used was a random forest classification model. So this model is able to predict with 86% accuracy what type of label it is. For example, this text is a Japanese word or a Japanese sentence. It's able to predict with 86% accuracy. And to understand our model better, we need to look at some learning curves. So learning curves is a way to measure how much data is needed for an accurate classification. From our learning curve, we can see that about 10% of annotated data from a textbook is needed to make a model of 86% accuracy. So the results from our model, we were able to get structured data. One column from item number, one column for Japanese words, and one column for English words from the actual image in the textbook. So from this output, you can use it in many ways. For example, flashcards, quizzes, or multiple choice questions. So we're going to go, for our case, we decided to make a flashcard app, and we're going to go into it in a minute. So this is our flashcard app. We'll provide you the link at the end of the presentation. So here you need to guess what the Japanese word is, and you can check the answer by clicking this button. So going back to our presentation. So in conclusion, information from images can be extracted with these tools of OCR, data annotation, and ML. And with this, we can reduce the work of annotation and hence increase cost efficiency. And from our results, we were able to find out that we only need 10% of annotated data to make a structured output that can be used in a flashcard application. So for further improvement, as you can see from our results, we were able to get structured data. However, there are some spelling errors. For example, in this case, you can see that the word public is spelled with a D instead of a P. And also in the bottom right-hand corner, the word WAP was not detected. So how we can improve on this project is to use either one or all of the following. We could use paid OCR tools like Google AI or Koa AI and do more pre-processing of images and train the OCR model with more data. And last but not least, I would like to thank my team. This is the team DEFT that make it happen. So Dylan, the OCR specialist, Tomo, the front-end developer, and myself. So thank you for making this happen and working together with me. So that's all. Thank you for listening, and please enjoy our flashcards app.
Cool. Awesome. We are ready to move into our second data science pitch for tonight. And we actually have the pitcher with us today. Noza, please come on stage for artificial non-intelligence.
Okay, good evening, everyone. Thank you for joining us in person and online today. And I'm Noza. I'm a data science student at Wagon Tokyo. And today I'll be presenting our project that we have been involved for the past 2 weeks, which is called Artificial Non-Intelligence. I think it's an intriguing name, isn't it? Yay. Okay. So you probably heard about the applications of the AI, which actually should be concerned, that we have to be concerned, worried, or even scared of. And I have to say, it is a topic that still remains elusive to the general public, and which is often masked in misconceptions. So, and the criticism or the concerns related to AI actually stems from the fact that from the misuses of the AI and manipulating the images and influencing public opinion or spreading the false information. And actually, so our project would like to change the narrative or claim, saying that AI AI can be not scary at all. It can be funny or even amusing. And another goal is of our project is to educate public about the deep fakes and kind of spread awareness. Okay, and well, actually today you will have a unique chance now to play the game. Are you ready? Ooh, cool. Okay, so the rules of the game are quite simple. So if you get the text right, you'll get a score of 1. However, if you get 3 times wrong, the game ends. And the objective is to try to get as many scores as possible before the game ends. I think it's quite straightforward. So let's start. Okay, what do you think about this text? AI generated? How many hands are there? AI. Okay. And the answer is? Well done. Good job. Okay. Next one, please. Human written. Oh. And the answer is? Ooh. Okay. Maybe give another try. Okay. What about this? Difficult. Human? AI or human? Okay. Oh, well done. Maybe the last try. What about? What about the human? No. Okay. So how was it? Great. Was it difficult? It was, right? And what we did actually, the reason that it was difficult, because we fed our model with the tweets. And the tweets are usually lack context, right? They're out of context. And so you simply don't know the author of the tweet, the circumstances under which it has been created, or the time frame, and so on and so forth, right? So, and another reason for that is was just our model is simply really good in creating something like a human-generated, human-like text, which is actually even hard for humans also to detect it, right? So actually about just to focus on the model itself, so we are using the GPT-2, which is autoregressive language model that is actually used to generating the text. And what it does under the hood, it actually studies the statistical patterns in the data set of millions of words collected from the web. And then it actually learns that massive corpus and tries to generate new text, that has similar statistical patterns based on the input, right? And then, okay. Another question. Here's the fun. Yeah, that's okay. So it is fine-tuned with only 11,000 tweets, which was, of course, hard for you to make a guess, right? Which was out of context. But the question comes, what do you think about the AI's power on that? Do you think it could make a good classification, detection? Yes? Okay, any idea about the score that the AI could give us for the classification? 99, wow, too optimistic. 80, okay, looks good. 62, oh, you know the answer, right? Well, I'll tell you. Okay, it is 63. Yeah, and the humans is 54. Yep. So as you can see, the machine learning models can actually easily outperform humans, right? They don't only outperform us. Actually, we can use them to detect the deep fakes themselves, deep texts themselves, right? So which means that like we can utilize them for good. Yet they're not perfect, which actually leads to our conclusion that always use your logic, use your mind, which is the best thing that you have to make the educated guess. Like we data scientists train our models to get the best score out of them. And always remember, the true test is not for AI to pass, but humans to fail. And as a human, never allow yourself to fail. Last but not least, this wonderful project would not have been possible without the help and assistance of wonderful people that you see on the screen. So there are QR codes. If you want to get connected, just read it and send us a request. Thanks. But just a quick comment, I'd also like to take this opportunity to thank Le Wagon teachers and staff, everyone who's out there. Thank you so much. Without your help, assistance, and guidance, and believe in us, this project would not have been possible. Yes. And of course, the online people out there, you have also unique chance to play the game. Please play it and have fun. Thank you.